So if you're a Sec 3 or Sec 4 student and your parent got you this book, but you're not very sure how to use it, I thought I'd record a short video on show you what I would do if I were you. Alright, okay, so with the end of your exams around the corner, or your O-level exams around the corner, I think it's very important how you make use of the last few weeks. And really, I would start my revision from the Ninja Notes because I think it's a very, very good place to start. So now let's assume you come across a prelim exam paper, or you're doing some prelim practice, all right, and you're not very good with chemistry. What I would do is I would have the Ninja Notes next to me. All right, okay, and I just pull it out, okay, and then first things first, I come across a question, I see it's on oxides. Now, hopefully you recognize that oxides come from the chapter of acids. So I will very quickly turn to the chapter on acids, and that's on page 23, okay, here, okay. Here are the 4 types of oxides. Now, I'm not sure if you can see because I know it's a bit small. Let me just try and make it a bit bigger. But 4 types of oxides. Okay, so you have basic, acidic, neutral, amphoteric. And they ask you here, what is an amphoteric oxide? Okay, so if you look at amphoteric oxides, you have zinc, aluminum, lead. So you look for whatever is given in the list. And here you have aluminum, and that gives you your first 1 mark. Okay, now then it moves on to talk about acid rain and stuff like that. So assuming again you haven't really studied yet, you got to go, okay, acid rain, which chapter is it from? Okay, if you haven't studied, maybe go and read through once first, the Ninja Notes, really. Alright, so acid rain is actually from the chapter of air and environment, alright, and this is on page 49, alright, or 50 lah, 49. Okay, so here you have concepts on air and environment you must know, and then here you're talking about acid rain. So if you read through, you have acid rain here. So acid rain can either be oxides of nitrogen or sulfur dioxide. Yeah, so you just give me either or, same thing, you get another 1 mark. Then hemoglobin, it's actually just above that. Here you have incomplete combustion, hemoglobin, carbon monoxide. Okay, so that's another 1 mark there. And finally, last one, volcanic eruption, it's sulfur dioxide, which is here. So notice on the first page, alright, already the first 4 marks in the back, if you simply just refer to your Ninja Notes. Part D is no longer in syllabus, so don't worry about that. Now this one here, alright, okay, I'm going to turn to page 9. Okay, so page 9, here, alright, you're given a couple of pictures, simple distillation, fractional distillation. Okay, now they ask you what is the purpose of the condenser. Now while it's not explicitly there, what a condenser does is that it cools down the vapor, so the gas gets cooled down, and then it turns it into a liquid. So that's your function. So here, if you're not very sure, good to put down into your Ninja Notes. Alright? Now here, the key idea here is this: although we don't study kerosene, it's not really in syllabus anymore, you need to know range of temperatures. Sorry? So when you see something melt and boil over a range of temperatures, you must, this is from the chapter of impurities. Alright? Okay, so if you turn to page 7, here, you will notice here, there are 2 effects of impurities. It will cause your substance to lower melting point, raise boiling point, number 1. It will cause it to melt and boil over a range of temperatures, number 2. So here, range of temperatures, why? Because it is impure, or you could say it is a mixture. Either way will work. Okay, so that is another 2 marks. Okay, now this one here, alloys. So alloys is from the chapter of metals. So under the chapter of metals, you're going to go to page 35, alright, okay, and here automatically you have the first one, definition of an alloy. So here you have a mixture of a metal and other elements, 1 mark. Drawing, here, another 1 mark. Okay, now physical properties of gold, it's not really in here because I thought when I came out with the Ninja Notes that it's quite simple. Most of you should know physical properties of metals. Good conductors of heat, electricity, malleable, ductile, shiny, so on and so forth. All from primary school, you should already know that, so just list any 2. And then here you're given a table on atomic structure. So you go to the chapter on atomic structure, page 15. Okay? And notice there's a very, very similar question here. So again, read through, determine how to find a number of protons, neutrons, electrons, you'll be okay. Now, key note here is this: if you see the word atom, alright, please bear in mind proton equal to electron. If you see a charged particle, this is an ion. If you see ions, you must bear in mind that protons and electrons are definitely not the same. So just watch out for that. Okay? Now, question number 4. Now, this one, I must admit, because it's not really a content-based question, might be a bit more difficult. So here, oxidation state of +1, we're looking for something with one valence electron. And if you look at Z, Z has that one circle valence electron. Answer is that. Okay, group 15, now this is the old syllabus, right? So group 15 means you must have 5 valence electrons. Now M has 1 cross, 2, 3, 4, 5. So M has 5 valence electrons, but 2 is M. Okay, proton number of 6. Now how do you know that? So if there are 6 protons, there must be 6 electrons. Agreed? If there are 6 electrons, electronic configuration will be 2.4. So for 2, 4 means that there are 4 valence electrons, correct? So you want to look for something with 4 valence electrons, and your answer is R. R has 4 dots. R has 4 valence electrons. Yeah? And then now you have here charge of 2 minus. 2 minus means it will gain 2 electrons. Now why gain 2? Why not gain 3? Why not gain 4? Why not gain 5? It gains 2 because there are only 6. Remember, it wants to get to 8. All elements want to get to 8, right? So for it to gain 2 means originally got 6, which has 6 valence electrons. 2, 4, 5, 6. T. Okay? Last one now. Gas. Element Q, gas. Predict molecular formula of Q. Sorry, I made a mistake here. Now Q has 1, 2, 3, 4, 5, 6, 7. Q has 7 valence electrons. It is a halogen. It must be Q2. All halogens exist as diatomic molecules. Okay, so this question, I admit it's not so simple. It's a bit more skill-based. All right, so later on, there are some questions that I also identify as skill-based, where just memorizing content is not enough. All right, okay, so watch out for that. Mole calculation, definitely skill-based. To find MR, you just basically take the AR of carbon, hydrogen, carbon, oxygen, oxygen, hydrogen, plus all together you should get 60. Now here, to calculate concentration in mole per dm cube, there is a formula here. Now some students will be like, how do you get the formula? It's not in your Ninja notes. Hold on, let me go to page 30. Okay, now in the Ninja notes, I didn't give you how to convert from gram per dm cube to mole per dm cube. But what I did was I showed you how to get from mass to moles. And that's actually formula number 1. Now you see, to get from mass to moles, you just divide by MR. To get from mass in grams to moles, you just divide by MR because it's per dm cube. So imagine you have 1 dm cube, all right, 1 liter, 1 dm cube, all right? It's some number of grams. How do you get to moles? You just divide by MR, all right, okay? You just follow the formula. And same thing, if I give you moles, you want to get the mass, you just times MR. Yeah, right, okay? So your concentration is 90, MR is 60, 90 over 60 gives us 1.5 moles per dm cube. Now what about the next question? I left it blank because I want to show you how to solve the 3-step method. Again, this is a skill-based question, right? So 3-step method, how do you do? How do you start? So step 1, always find moles first. I give you 500 cm cube, 10 mole per dm cube. Oh, what do you have? Some students are like, sure, I don't know how to do moles, I don't know how to start. If that sounds like you, what you want to do is you want to label, oh, this is volume of solution. And this is concentration of acid. Volume, concentration. Which formula? Oh, volume, concentration, is it formula number 3? Yes. So volume, concentration, formula number 3, all right, mole is concentration and volume. You take 10 and 500 over 1,000. Remember, you must always change volume to dm cube. Yeah. So you take 10 times 0.5, you get 5 mole. That is step 1 done. 3-step MRS. It works most of the time. Step 1, always find moles. R stands for mole ratio. All right. Okay. Mole ratio of whatever you're given, your acid to your calcium oxide. Your acid to calcium oxide is 2:1, 5:2.5. Then finally, you want to solve. Now, how do you solve? What does the question want? The question wants mass. And so again, we're going to go back to formula number 1. Oh, mass is very simply mole times MR. What's the mole? Oh, here, 2.5. What is the MR of calcium oxide? Again, this one you got to go and find periodic table. Or in fact, I think it's given, no, it's not. So calcium in the periodic table is 40 and oxygen is 15. So that's MR of calcium oxide. So you take 2.5 times 56. All right, 2.5 and 56. You get 140 grams. Okay, so that's how you do your mole calculation, 3-step method. Again, it's all in the Ninja notes. So please go and refer to it, all right, make use of it. Now, another one which is skill-based is QA, all right. I could give you the notes, but if you're not sure what to do with it, you're going to get stuck. So basically for this question, you want to identify A, B, C, D, E, F. It is 6 marks. It is about 10% of your written paper, again for combined chem. For pure chem, I don't believe you get a flow chart. You might get a flow chart, maybe it's 3 marks, okay, so it's not a lot of marks. Anyway, for combined chem, all right, okay. Now, I will always look for sodium hydroxide or aqueous ammonia first. So if it's not given, I'll figure something else out. I always look for sodium hydroxide, aqueous ammonia. Oh, here, aqueous ammonia, check. White precipitate. Okay, let's go to page 27. All right, so that's page 27, right? Aqueous ammonia, white precipitate. Add excess, dissolves. Oh, and this is key, all right? If you miss this part out, you will always not know what to do. 2 conclusions. Every one observation, you must have 2 conclusions. The first conclusion is this is zinc hydroxide. And the second conclusion is that you have zinc ions present in solution E. You need to be able to list this down here. Most students forget. They're like, oh, I know the white precipitate, and then after that I start. All right, so you must be able to also tell me what the ion present is. Excuse me. So that's 1 mark. Okay? Now, let's look for something else that's simple. You see gas, white precipitate, lime water. This is carbon dioxide gas. Now, when do you get carbon dioxide? Think through your whole syllabus. There is only one chapter where we study carbon dioxide being produced, and that is acids and carbonates. Maybe your school does thermal decomposition of metal carbonates, but if not, not all schools do that. All right. Under the chapter of acids, bases, and salts, you have one reaction: acids and carbonates, salt, carbon dioxide, water. So to get carbon dioxide, your acid must react with a carbonate. All right. So you have compound A. Compound A is your carbonate, and you have metal B. So again, carbon dioxide gas means what? Means that A is a carbonate. Okay. Now, here's another interesting fact. Okay, I don't know whether or not you managed to see that. Your B, after you add acid, still present. So metal B doesn't react with acids, which means metal B can either be copper, or silver, or gold. Sorry, gold is AU. All right, okay. And now, what is metal B? All right, okay. So metal B, you heat strongly, black powder. Oh, blue, blue. There's only one blue solution in your syllabus, and that is copper something. All blue solutions must contain copper ions. It could be copper chloride, copper 2 nitrate, copper 2 sulfate, we don't know. But here, you add sulfuric acid, oh, it's copper 2 sulfate. Okay, so that is D. I have 2 marks. I have F, I have D. In order for you to form copper 2 sulfate, what metal do you think we are dealing with? Copper, silver, gold? Copper. I have the 3rd mark. Okay, and when copper heat with oxygen, it will react to form copper oxide. I have the 4th mark, so 4 out of 6, 2/3, 66%, B3. Now let's try and get the last few marks, okay? We need A and we need E. Now here we have zinc ions, okay? Now this E was formed after you add sulfuric acid. And sulfuric acid will always give you a sulfate. Again, if you didn't know that, hydrochloric acid gives you a chloride, nitric acid gives you a nitrate, sulfuric acid gives you a sulfate. So this is zinc sulfate. Yes, we have done E. Alright, so we're down to one more last one. What is A? It's a carbonate, right? What carbonate is it? Is it magnesium carbonate? Is it iron carbonate? Of course not. It must be zinc carbonate. Alright, because you have zinc ions present in the flowchart below. And we have our 6 marks done. So this is a skill-based chapter, alright, okay? Again, just by looking at this here, doesn't really mean you can get it. It's a lot of thinking involved, forward, backwards. But the most important one is, for every one observation, please write two conclusions. Yeah, all right, okay, watch out for that. Now, I'm going to skip the balance equation because, yeah, again, I want to show you how to use the Ninja Notes. Let's not lose track. Ninja Notes, okay? Now, Organic Chem, my favorite, because why? A lot of it is inside. Let's turn to page 52. Okay? So 52, or is it 53? 53, okay? What page is this? 52. All right? Now, describe conditions for fermenting glucose. Oh, it's basically here. 37 degrees Celsius, no oxygen gas, yeast. Write balanced chemical equation. It is below. Again, 3 marks just by memorizing facts. Okay? And then when ethanol is left to air, it's oxidized. Okay, fine. Draw the product. So when ethanol is oxidized, what do you get? I don't know if you know this, but when ethanol is oxidized, you get here. When an alcohol gets oxidized, you get a carboxylic acid. So when ethanol is oxidized, you get ethanoic acid. Just draw ethanoic acid. Another 2 marks. Show all bonds present. Full structural formula. That is a whopping 5 marks just by content here. Okay? Now, okay, redox, skill-based, not the most simple. Alright, okay? I'm not saying that it's not in there. Redox definitely is here. All the templated answers are here, but for redox, I think you need to know how to calculate your oxidation states. Hold on, I forgot the page. There we go. It's on page 33. Okay? So you must be able to calculate oxidation states and things like that. So maybe you forgot. I will show you. Now, first things first, always fill in elements. Elements first. Elements simple. Element always no charge. Right? And for redox, ignore the number in front. Okay? We don't look at that. After you do that, how to calculate the rest of it? Very simple. Split into elements. Each oxygen is always -2. Again, in compounds, oxygen is -2. 2 of them is -4. This is +4. Okay? This is -2. This is +2. Oh! What happened to carbon? The number increased from 0 to +2. Right? Look at the oxidation state. Carbon goes from 0 to +2, right? What happens? Oxidation state increase means it is oxidized. That's how you use the chute. Look at the tin. From +4 becomes 0. Number from +4 becomes 0 means the number drops. So oxidation state decrease means reduce. And then after that, you go and use your template answer. Where is it now? Give me a second. I think it's here. There we go. In terms of oxidation state. Okay, so name of element in reactant or reactant is oxidized. So in this case, carbon is oxidized. All right, follow the format. How come oxidation state of carbon increased from 0 in C to +2 in CO? Follow the format. It's there. Template for you already. Okay. What about you can tell me SN in SNO2, or you can tell me SNO2 is reduced. Okay. And then again, what is the format? Oxidation state of tin, SN, decreased from +4 in SNO2 to 0 in SN. That's it. All right. Okay. So that's why it involves both oxidation and reduction. This one, reactivity series, where tin is placed. If it can be reduced by tin, by carbon, it is below carbon. So it's below carbon. And then tin and magnesium nitrate. Now, sure, I don't know what's happening here. So go to the chapter on metals. Tin is a metal. Go and look at the chapter on metals, which is just the next one actually, and look at the reactions here. Tin and magnesium nitrate. What reaction is that? Is that with water? No. With steam? No. With acid? No. Is that thermal decomposition? No. Alright. Then what reaction is it, Cher? It is, hold on, it is here. It is part 4. It is displacement. Oh yeah. So again, you must be very clear on all the reactions, and reactions again are in Ninja Notes. So again, if I were you for combined chemistry, the idea is very simple. Zoom in on the chapter and then use the Ninja Notes, go and find the relevant concepts you're being tested. Alright, okay, so just watch out for that. And then of course there is no reaction because why? Tin is less reactive than magnesium. Alright, okay. Tin cannot displace magnesium from magnesium nitrate. Alright, okay. Why copper sulfate, iron sulfate, can be removed from tin by running water. This is a suggest question. Unfortunately, most suggest questions answer are not in there. All right, but you think, how come you pour water can remove? Because they are soluble in water and therefore they can be washed away by water. Okay, so that one is a bit interesting, suggest question. Now I'm not going to do the section B because I again just wanted to show you how to use this set of notes. So I hope you found it useful and I hope you now know how to revise for your next upcoming chemistry exam. I'll see you in the next video.